Well, thank you so much, everyone, for your patience. We'll go ahead and get started with our first keynote of the day. So it is a great pleasure for me to welcome Dr. Radhika Khosla, who is an associate professor at the Oxford School, Smith School of Enterprise and Environment, and the School of Geography and the Environment, and also the research director of the Oxford India Center for Sustainable Development. So as you can see from her many appointments, she has a very broad background spanning physics, geophysics, and many other disciplines. And she draws on these interdisciplinary techniques to study urban transitions in developing country cities and the tensions that this gives between improving quality of life and also sustainability goals and climate change mitigation. So I'm very happy to welcome her today to be our first keynote speaker.
Thank you so much, Irene, and thank you to all the organizers for having me here. This is an unusual audience for me, and so I'm definitely here to learn. And it's been interesting to think about giving a talk on climate change and sustainability in the context of development to a sort of non-specialized audience. So I'm looking forward to doing that, and thank you again for having me. All right, and I'm going to walk you through this question of sustainability transitions in a changing climate and link to the question of how we address this in the context of development. And I'm going to draw from the example of India while I do that. And I'm looking forward to talking with Araba after that on some of the themes that emerge, and then also with members from the audience. Now, let's begin by sort of taking a step back to about 400,000 years ago, when we look at CO2 levels that have existed for the Earth. And this is an image that many of us might have seen before, but there's almost a certain way in which we're immune to looking at these. But if we take one more look at it, what we see is that over these 400,000 years, we've seen carbon dioxide levels in the atmosphere go up and down, and they've usually varied between sort of below 200 to about 300 parts per million. But then if you zoom in to the sort of rectangular box up front, if we start looking back about 1,000 years, something very different starts happening, and you see a spike up in carbon dioxide levels in the atmosphere, which just sort of zoom up 1800 onwards, so post-industrial revolution. And where we are today, so this was a number that I had pulled in June, and we're now at 420 parts per million in terms of carbon dioxide levels in the atmosphere, and that is more than it's ever been over this 400,000 years. So it's really much larger over a very extended period of time. And we've tried to address this problem globally, right? Like we've been trying for the last 30 years to think through and act in international climate change negotiations. I want to remind us that the first negotiations took place in 1992, and that is a long time ago. I know we're all looking forward to the COP discussions that are later this year, it's the big climate change conference that's going to take place in Glasgow. But these conferences have been going on a long time, and since the first COP, which was in '95, humans have emitted more than 765 billion tons of carbon dioxide, and the mean surface temperature is now 1.1 degrees Celsius higher than what it was in the pre-industrial world. Just in terms of context, the science tells us very clearly that if we hit 1.5 degrees of warming, we're basically looking at unprecedented changes in the way we live, in the sorts of impacts we would see, and the kinds of extremities that we'd have to deal with. And we are already at 1.1 degrees Celsius above pre-industrial warming, and we're warming, the Earth is warming at about 0.2 degrees C per decade. So it's warming faster than ever. And at the rate we're going to reach that 1.5 degree target anywhere in the next 10 to 20 to 30 years. And that is real cause for worry, because as we've seen, and these are just images from the last few years, every time I do this, there are so many more examples of the types of extremities that we're seeing, where you have areas that are completely unprepared for floods or warmth or heat waves or wildfires that are interrupted, and there is immense loss of life because of these extreme weather events that are no longer rare, but rather have become quite common. So, the big question for us is can climate change be solved? And it's very hard to think about solving climate change because climate change is what is technically called a super wicked problem. And what is a super wicked problem? A super wicked problem is one where you have many interrelating aspects. So these problems are economic, they're political, they're social. At the same time, they also involve, they're biophysical. So they involve the atmosphere, the ocean, biological systems, and they're so complex with all these different variables that they become very difficult to think through in terms of solutions. What we do know is that we need to reduce CO2 emissions to zero. That's where we need to get to if we are to get to a point where we need to curb warming. And the IPCC 1.5 degree report lays out two ways in which we can do that. There are basically only two ways in which we can get to that temperature target, and the graph on the right hand side here tells us that you don't need to sort of look into it too carefully, but if you notice, there are four different scenarios where warming can stay below 1.5 degrees, and out of those four scenarios there are three that have the red in it and only one that doesn't have the red. Now, the red is the use of negative emission technologies. So that is the use of technologies that allow you to remove carbon dioxide from the atmosphere. So that is either through capturing carbon dioxide from the air, storing it under the earth. There are different kinds of new ways in which we're thinking through negative emission technologies. None of these is really available to scale right now. The only other way we can get to 1.5 degrees is if we take a serious look at energy use and reduce energy use. So really energy in some sense lies at the heart of how climate change can be thought about in terms of being solved if solving per se was possible. Now, the problem with energy, and this is really a problem that is so it's so poignant in the developing world, is that we're now looking to a future where we need more energy as the planet, as population, as as sort of people across countries. We are looking to a future where we need much more energy, more than we've needed ever before. But we need to do it and we need to consume in a way with much fewer emissions. And that kind of future has never really been one that we've considered, because up to now we've consumed a lot of energy, but always done it by having many more emissions. Now we need a future where you need to have more energy, but with fewer emissions. And this is complicated because energy use is continuing to rise. It is still dominated by fossil fuels. Fossil fuels are necessary because in many ways, in many countries, they still underpin modern life and energy security. And providing energy security to people is a priority for development. So, for example, in 2014, which was not that long ago, more than 3 billion people had no access to clean cooking fuels. And that is that's half of the world's population not having access to clean cooking. And in 2018, for the first time, the world's population without access to electricity fell below 1 billion. And that's a milestone. It's a milestone to be able to say that the number of people who don't have access to electricity is below 1 billion. I mean, there's still an appalling number that don't have access, but even so, there's progress being made. But this progress has come with a lot of uncertainty around how these different transitions, whether the transition is towards more energy use, whether it's towards energy access, whether it is towards urbanization, whether it's towards clean cooking or towards decarbonization, how are these different transitions going to pan out? So the question of climate or development is then really important because in many ways that is where a lot of this is going to unfold. And again, what we know from the science is that to be able to build infrastructure in fast growing cities in developing countries, we're going to use about 4 times the amount that was used to build developed world infrastructure. So basically, in the developing world, in some sense, because of the stage of development that it's at, is going to consume, if it continues on business as usual, large amounts of carbon dioxide to be able to reach levels of development that many of the Western countries are at today. And that poses serious complications for the climate future of the world. But these complications are not just about carbon budget or climate futures. There are also serious ethical dilemmas about who has the right to develop, and is that quality of life available for all or not. So I'll tell you a little bit more about what I mean. Now, we can ask the question, we've ended up in this sort of climate crisis, and who is responsible for it? So if we look at this graph here, it tells us that who the largest annual emitters of carbon dioxide emissions are in terms of countries. So this is going back to about 1800. And you can see that, and on an annual basis, right? So on a year-by-year basis, who emits the most? And you can see that China is, is up there, as is the United States, as is the EU, India, Russia. And so these are countries that in the last sort of 10, 15 years have been emitting large amounts of carbon dioxide on a yearly basis. And there is an argument to be made that this is where responsibility lies in terms of creating the problem. Now, the trouble with sort of data in some sense and how we cut our data is that we can use our data to tell us what we wanted to tell us, right? So if we look at things in another way, there's a different image of responsibility. So if we look at cumulative emissions, which is who is responsible for the emissions that have accumulated in the atmosphere since 1800. And the reason why cumulative emissions is important is that carbon dioxide is a gas that lives in the atmosphere for 200 plus years. So it doesn't matter, it's agnostic to when it was put into the environment, whether it was put into the environment yesterday or whether it was put in 150 years ago, it is still producing the same warming. So cumulative emissions, therefore, are really important from a climate perspective. And if we look at who is responsible in terms of putting the most amount of carbon dioxide into the atmosphere, we see a very different set of countries which emerge. The United States comes up front, then the EU, China, Russia, United Kingdom, and then countries like India and Brazil are much lower down on that list. Now, there's yet one more way in which we can do this, which is to say, what about emissions per person? Because different countries have different populations, and the sort of there's a large school of thought that thinks that the right way to calculate responsibility is to say, as an individual living in one of these countries, how much have I contributed to the problem? And if we look at it in that way, you see another very different set of numbers which emerges, which is that in the United States, per person emissions are the highest, followed by Japan, which again is a country that wasn't showing up in the previous two slides, then China, and then the United Kingdom, and then India again is much lower. So, I think in the context of those of us who work with numbers, this question of how responsibility is allocated is really one that we've not been able to sort out completely in our climate debate. And in a way, it's been at the heart of why we've not been able to think through a solution, because there's this constant pointing of fingers between countries in terms of who really created this mess to begin with. So, responsibility aside, I think what is important about development is that in a way there's also an opportunity within it, right? We're also at a place at the planet where we can't just point fingers and the negotiations, but even the state of the atmosphere in some sense demands that everybody now acts towards this issue. And developing countries actually have an opportunity here. They have a moment to do things differently, because when you build infrastructure, you actually are locking in consumption patterns for a long time to come. So buildings, roads, transportation, bridges. These are all some of the longest living components of any economy. Once you put them in place, they're there for 50 years, 100 years, even longer. And so there is a real moment in developing countries to be able to shape such infrastructure in a manner that it leads to a low carbon way of living. And the reason why that is important is that how individuals live, how you and I live, is actually approximately responsible for 2/3 of global greenhouse gas emissions. So households like yours and mine are responsible for 2/3 of global greenhouse gas emissions. And the main ways in which that plays out is in the way that people use mobility in homes, so in the residential space, and then in food. And each of those areas is actually responsible for about 20% of global lifestyle emissions. And so there are, these are pockets in some sense where you can think through the question of not climate or development, but rather how can you have both? What are the ways in which societies are able to develop and be able to reach a quality of life that is that is one that everyone deserves, but do it in a manner that actually does not kill the planet, but is one that is low carbon or zero carbon. Now, I use India as a way to talk about some of these issues, but also to demonstrate some of the tensions that come about when we are working in the context of a developing country. Now, India is an interesting example because in some sense, what happens in India in the climate context is relevant not just domestically, but it has global relevance. And the reason for that is that, as I was just saying, the largest proportion of global energy demand growth is going to come from developing countries. That's where the biggest demand is going to be. And in terms of energy demand, the largest energy demand globally is going to come from India. And so what happens in India in some sense is important globally. And the question is, how do we negotiate that tension between growing energy consumption for development and protecting the environment? So let's take a step back and let's, just contextualize India a little bit in the global context. So if we look at GDP numbers, India is in the top 5 economies of the world. It is placed with countries like Russia, China, Germany, and so it's sort of, it's seen as an emerging economy. If we look at total greenhouse gas emissions, India is in the top 3 emitters globally. So when it negotiates in climate negotiations, it negotiates with these big superpowers because itself is a big emitter. And so there's this real sense that it is this emerging economy. However, the other side of the coin is that it also has elements that look very different from that of an emerging economy, but rather one, as a colleague has said, of a premature power. So if we look at things like GDP per capita, India actually ranks very low. If you look at the multidimensional poverty index, which is an index that looks not just at poverty as a function of income, but also around indicators of education, of health, India actually ranks really badly, much closer, to sort of say its neighbor Bangladesh, as opposed to other countries that it is clubbed with in the negotiations. And similarly for greenhouse gas emissions per person, India's greenhouse gas emissions per person are much lower than with some of the other countries. So there's this interesting duality in the case of India where it negotiates and positions itself, with the large superpowers, but in many ways, some of its other indicators are really those of a very different set of countries and point to a very different set of circumstances that underlie the domestic context. So the interesting thing about the region is also that at the moment it's shaping and participating and undergoing a number of different impending transitions. First of which is urbanization, and the largest urbanization transition in history is taking place in the country right now. So Indian cities will host 200 million more people by 2030, and the urban population is set to double by 2050. It's not just urbanization, it's also infrastructure. So 2/3 of the buildings that will exist in 2030 are to be built between 2010 and 2030. So that's just an enormous amount, and an equivalent in some sense to building a new Chicago every year. And in terms of access, about 800 million people still lack access to clean cooking. So again, you can see that there's this real sort of contradiction in some sense, where you have huge urbanization, huge infrastructure growth, huge gaps of access, and these uncertainties make it very difficult for for sort of accurate modeling and scientific sort of projections around how the future will unfold. I'll point to that in this graph here. So this is some of the work that we had done before the Paris negotiations. And if you look at the left-hand side, the y-axis, so these are the projections for what carbon dioxide emissions for India would be in 2030. And the x-axis is different growth rates, because again, that's another place of uncertainty in development is, you don't know what rate the country is going to grow at. And if you look at the different dots, all the dots are their different studies. So they're different modeling studies. And what we did was we wanted to get a sense of what do the sort of the best modeling studies, the studies that the government uses or has commissioned, what do they tell us about where India will be in 2030? And you put all these studies on the map and you actually see that they're all over the place. And actually the range of projected emissions, so the range of what the emissions will be in 2030, the uncertainty in that range was as much as the current emissions, right? So there is almost 100% uncertainty in where the country is going to end up. And again here, I'm sort of using this example as a way to point to some of those tensions that come up when you're trying to make such assessments under the context of the multiple transitions that are taking place in a developing economy. Now, in India's case, these transitions and these uncertainties are linked to both questions of energy demand and supply. It's not clear, is the future of Indian energy one of coal, or is the future of Indian energy one of renewables and solar? We're now at a place where solar prices are very close to coal prices, even cheaper, but a large part, 60%, 70% of the country's energy system is projected to be fossil fuel based and coal based. And so it's an open question. Similarly, what is the country's demand future going to be? Is it going to be, what is the manner of urbanization? Is it going to be urbanization that is energy efficient, or is it going to be energy inefficient? And all we know in some sense is that demand will grow, but that magnitude of what the demand will be is amenable to intervention. And the energy models themselves show an uncertainty of 150% for 2030 projections. And that is, it is a very large amount of uncertainty from which to make informed policy choices. Now, I'll use the rest of the time I have to give some examples from the work that we've been doing, focusing on residential electricity use, because that's another area that's really important within energy use. Like I was saying, homes are responsible for 2/3 of global greenhouse gas emissions, but households are. But in India, homes are currently using about 25% of total electricity use, and residential electricity use in India has grown 50 times since 1971. In 2050, it's going to occupy 85% of India's floor space. But if you look at projections, and these again are just projections from different studies, including the IEA, so sort of global studies of the highest strength, you see that the numbers again are sort of all over the place. The projection can be anywhere between 5 times to 6 times, and we don't really know where the country is going to end up. So some of the work that we've been doing is to be able to build an empirical base to examine energy service transitions. And the reason we're doing that is, in the context of development, it's very hard to get accurate data. So it's hard to be able to trust the surveys and to trust the available data. And as researchers, we often go in and collect that data ourselves. And so what we've been doing is looking at both low-income housing and at large cities like Delhi to be able to examine what are the energy services and technologies that households demand. So if you're a household that is growing in income, that is urbanizing for the first time, maybe you're moving to the city for the first time, buying a house for the first time, what is the energy service, what is the energy technology that you buy first, right? What is prioritized within that context of development that is linked to energy use and climate change? And what are the kind of behaviors and drivers that underlie those energy service choices? So I'll give you a sense of the answer to some of that question. Now, the way we do this is if you look at studies of consumption in, in sort of in the US or in Europe, the basis by which households are ranked is by income, right? So you think about households in terms of what their income is, and you use that as a basis of saying this is a high earning household, this is a low earning household. We can't do that in a developing country context. We can't, because when you go into households and you ask them what is the amount of income that you make, you don't get an answer that you can trust. Often you don't get an answer at all, or they're all over the place. And I think this is a key difference in terms of how researchers sort of manage the tensions of being able to work in these sort of transitioning contexts. Now, the way that we've dealt with this is that instead of thinking about income, we rank households on their ability to consume. And so we developed a model where we're working with an index which is based on the ownership of daily use assets. So things like smartphones, water purifiers, gas stoves, air conditioners, cars, TV. And these are things that when we go into the household, you can actually see. And so you know for sure whether a household has that or not. And we've used that to be able to rank households in terms of those that have a high ability to consume and as proxy for high income and have low ability to consume. So I'll give you an example of the types of services that are being demanded. So if you look at the x-axis here, you can see on 0 to 10 is basically households that are ranked low on this index, on this asset index. And then as you go higher up, you have households that are ranked higher on the asset index. And what I'm plotting is basically which are the appliances that households want and buy as their ability to consume increases. So if we just move from the left hand side of the x-axis, you can see that the first thing. So look at the dark. Look at the light blue actually. Okay, let's start by looking at the dark blue on top, which is the fan, and you can see that from 0 to 10 or 10 to 20. So early on on the asset index, you have households that are buying fans. It's the first thing that you buy. Then the next thing that you buy, and this kicks in around the 40 to 50th percentile, is a TV. So you actually buy a TV way before you buy a fridge. The fridge only kicks in at the 70th or the 80th percentile. It was interesting to be able to see that, right? Like there's a prioritization of entertainment over a fridge, which could be seen as a necessity in the way that households are urbanizing and what they are prioritizing, particularly in low-income homes. It wasn't intuitive in terms, but that's what we find. We compare this with other countries, and this is not our work, it's taken from another paper, but you can see that. So you have Brazil, which is the light blue, India, which is the dark blue, and South Africa, which is the green. And you can see, so up top on the left quadrant is the mobile phone, and you can see that actually in India, the lower income households, acquire a mobile phone quite soon compared to, say, a place like South Africa. The right-hand side quadrant is the refrigerator. And here you see that in Brazil and South Africa, people buy a refrigerator early on. Like as they have the ability to be able to buy one, they will get it. Whereas in India, a refrigerator just comes later, which is interesting for a very hot climate. On the TV, and this is similar to our results, you see that actually India does, even if you're very low income, you're going to buy a TV first. And whereas that's not the case in South Africa, you aim for a TV much later on, whereas there and you'd aim for a fridge before. So it's useful to see what priorities households give to the way in which they consume energy. And all of that adds up when you're talking about the scales of growth that you see in countries like India, but also in countries like South Africa and Brazil. It adds up to how, in a way, we're responding to the climate change issue. I'll make one last point before I end, and this is on thinking through and determining what the drivers of electricity use are. Now, in our modeling work, and this is how global models, global climate models, global energy models, this is how most modeling is done on electricity use projections. We basically use a number of structural variables, right? So what are the appliances owned, what is the housing category, what are the number of households on the floor. That is the way in which you make projections about how much energy is going to be used. Sometimes socio-demographic variables are used. Very rarely are behavioral variables used, right? So by behavioral variables, I mean variables that allow you to model for the differences in the behaviors around energy consumption. And what we wanted to see was that, is there a way in which, like, what actually makes up energy use? If we had to project it accurately, is it accurate for us just to be able to say income and the building type is enough to project energy use? And so we were able to do a study where we had identical homes and over a period of time collect this data. And what we found was that if we looked at the electricity bill of these homes and we looked only at the material variables, so that is, things like the structure, the amount of area, which is what traditional energy models use, you could only explain 23% of the variation in consumption or in electricity use. If we use demographic variables, so things like class, caste, gender, education, you could explain much more of the energy consumption. And if you then included behavior, you could actually explain the largest amount of variance in energy consumption. And this is really, it's been very useful for us to be able to determine this statistically, because what we're able to say now is that, you're not just, we're in a world where you're not just making projections about energy use based on the structure or the area or income, but rather around how people actually use energy. And that makes a difference in the way that modeling results are. We don't really model for this in mainstream. I wouldn't say mainstream energy models are accounting for behavior yet, but there is definitely a growing conversation about the need to be able to do that. Some examples of that are that households that have exactly the same appliances have very different electricity bills. And we were struck by that, right? Like if you have exactly the same appliances and you're a low income home where there's not much variation, in terms of what you could do or not do, why is the bill so different? And in many ways, the answer for that is when we talk with these families, there are families that are turning their lights off and using the street light to be able to meet their electricity needs. And at the same complex, there are families that are, have lights that are on all the time. They have aspirations to buy large TVs. They want, they complain about the lack of a neighborhood mall. There are families that have the fridge on, all the time. And there are other families that turn the fridge off, right? So there are families that are taking the fridge and using it as, more as a storage device, because culturally, the way to think about food is to favor fresh meals. And these are the kinds of nuances that don't make it through to our energy models. And so some of the work that we're doing is actually to be able to bring that role of behavior and culture into the discourse around energy and climate change, because actually it adds up and has a real role to play in we're thinking about climate mitigation options. This is similar work that we did in the Delhi region. And again, here, this is, I just, want to show that the pattern is very similar. When you are, when you're the lower income decile, the first thing that you buy is a TV. And you buy a fridge next, but much later. And then because this was in the Delhi region, the appliance that you then begin to think about buying is a washing machine and a water purifier. And the sort of the next big question for us in this sort of energy issue is cooling. And we could do this in Delhi because the population is wealthy enough to think about owning air conditioners. But even then, so what you have here is you see that the orange line on top is the fan, and everyone owns a fan. The gray line is coolers, and that's it's a cooling system that's not, it's quite local, it's not so energy intensive. Most people start owning a cooler in the second or third decile. And then it's only the most wealthy, so you see the pink line only starts picking up around the 80th or 90th percentile, and that's when people start buying air conditioners. Now, air conditioners consume about 1,500 to 2,000 watts of electricity. A fan consumes about 60 to 100 watts of electricity. So you can see that as people get wealthier, as they buy more and more air conditioners, the demand on the system for energy consumption is going to be upped by an order of magnitude. And when you add that up, there is a real question about energy demand and the future of cooling. It's famously said by Lee Kuan Yew about Singapore that air conditioning changed the nature of civilization by making development possible in the tropics. We're now at a place where 1.1 billion people face risks from lack of cooling, and as extreme heat events get more and more mainstream, the number of air conditioner increases is already projected to be very high. In fact, the IEA says that the statistic is 10 new air conditioners every second will be sold for the next 30 years. So that's 10 ACs every second for the next 30 years. And so the future of cooling, in some sense, presents one of the most significant levers for us to shape global energy demand. And so what you see here is that by the end of the century, air conditioning is going to be consume much more electricity than heating does. And again, this is important in the context of development, because where most of this energy consumption is going to come from is in developing countries that are managing this tension between climate and development. So I will end here. This is my last slide. In doing this work on the tensions between climate and development, our goal in some sense is to be able to identify where are the socio-technical tipping points, where are the points in these transitions that different countries are making, where you can shift the system towards being low carbon. And this is an example that is a reminder that it's possible to do this. So this is Easter Day Parade in New York City in 1900, and you can see that the primary mode of transport here is chariots. And then that same street, just a decade later, the primary mode of transportation became cars. And so, as a society where, we have done this before, and in many ways, the one of the key issues in the work we do on climate change mitigation now in the context of development is identifying these and being able to then implement them. So I'll stop there and thank you.